So, one of the kind of nice things about this problem is how it's broken up. If you look at the size of the bins, that will help tell us the distribution that makes the box plot. So I'll give you a second to get that. You're good. When we're working with histograms, the y-axis pretty much always going to tell us the frequency. So I go through and I use my frequency to figure out how many people total were here. I had 1 and 2 and 4 and 5 and 3 and 7. Four, yeah. 3, 2, maybe. Yes. Okay. It's hard to kind of see straight across there. Like, yeah. Yeah. Okay. How many people total, or whoever we're talking about? How many total do I have? 50. Okay. So, in a box plot, we know starting from 0 is our first distance from the bullseye. We need 25% of the data to be in that whisker, right? What's 25% of 50? Yes, because we cut it in half again, right? But I can't have half of a result. That's where that result gets taken out. Right, so if you imagine 50 numbers, our data points. You with me, Bola?
Yes, sorry.
No, you're good. I was waiting. 50. Cut in half, 25 is left over here, right? That's our first two quadrants. Then cut it in half again. I end up on the 13th number. Take it out. Now I have 12 on the left of that, 12 on the right of that. My bottom half is now broken up into 12, 12, and quadrant 1 kind of got like taken out.
Oh.
So, quadrant 1 is my 13th result, right? 3, 7, 12.
You're recording, right?
Yes. Why? Are you not paying attention now? We can pay attention later.
No, I haven't done the homework yet.
Okay. Well, you should do this with us.
Okay, so then...
So, where does that fall? My 13th result falls right about the 6th range.
Isn't it the first part?
Yeah, so that really
Oh.
makes our whisker. Right, so from 0, really it would have to stretch all the way down to 0, because our results start at 0. That's our whisker. That's our first 25% of the data. Then we start our box and go 12 more numbers. 1, 2, 3, 10. Okay, it's going to end in the middle of here. Does that make sense? We went 12 more. Then we go 12 more. So wait, this was 10. I used 2 of those. So I still have 5, 11. I'm going to need 1 of these. My box ends there.
Can I just randomly guess and read a box plot?
No, you can't just randomly guess. We got to break up the data into quadrants, right? Quartiles. And then the rest of my results are the tops. I used 1 of those, so 5, 6, 7, yep. Now, we aren't 100% sure, but that's approximately what it would look like.
So then, after making both the box plots, would the right hand and the left hand?
The right hand's going to be closer together.
What do you mean?
We're going to do it. I think that one's 5. Again, if you said there's 50 here, We need 12 in the first quartile.
Oh, so then you take one from the other.
Then we need 12 in the next quartile. There's 9 left here. We need 3 of those. So there's 5 left over here we didn't use. 11, we're going to come into here. That's how our box plots will work.
So then wouldn't the right hand be not precise because it's oh, you want the distance to be smaller.
You want your data to be closer together. The tighter concentrated your data is, the better your results are.
No.
So, let me give you an example, because this is kind of weird, because it's talking about distance from bullseye. If I was trying to collect data on heights of 7th graders, I would expect them to be relatively close together. But if I go to a school that involves like kids that have been held back a couple years or kids that are like, I might have a really wide spread of data. So that's going to mean that my results are further apart from each other. This means my results are more closely concentrated. Not that it's better or anything like that, but that just my results are more closely concentrated. The smaller my quartile sections are, the more data, well, not the more necessarily, but the closer all that data is. There's the same number in this side of the box as there is in this side of the box. These are just closer together. There's the same amount of results here as there were there. But here it's closer together.
Okay, so I skipped the last, I skipped D. So then, if you had the box plot and all that, couldn't you, so, what?
What? Sorry.
What would you do? Would you, because you know how you have your quartile 3 and quartile 1, like, on some of, on top of the, histogram?
Mm-hmm.
So then,
Well, box plot.
the box plot
Yeah.
is above the histogram.
Yeah.
Yeah. So then, the quartile 3 would be like in between 6 and, or.
You'd have to like make a guess
Yeah.
what the result is.
So then the IQRs, since it would be.
You're kind of guessing.
Yeah.
Yeah. So this, the IQR, or the quartile 3 falls in here, so it's probably 6 something. 6.2, 6 whatever.
Mm-hmm.
Even if we say like, because this is 7.5, right? So let's just say 6.5. I really need a smaller pen. And then down here, we just had got into there, so maybe that's like 2. So the IQR here would be 4.5. So then it says, how many IQRs above the median Lou's better hand is? So median's always that middle, so then we can function. Alright. We gotta start the lesson. Yeah, kind of.
Well, I mean. Yeah. Yes, so we have double.
Yeah, but that wouldn't really match the name of accelerated setting. Taking a birthday. Don't worry, today's stuff is fun because we're talking about probability. Let's say I want to know what goes in trail mix. I don't really want to talk about soup, so forget about that. Do I need to eat all of the trail mix to know what goes in it?
No.
Who can raise a hand and explain to me why? Alex, what do you think?
Because you can see what's, well, you can see what's in some of the trail mix. And
Let's say it's in a really dark container. Sorry, I know I'm changing parameters on you now, but let's say you can't see it, you can't look in it. It like absorbs the light. You can reach in, you can take trail mix, you can eat it.
Can you look at it when it's in your hand?
Sure, yeah. Ian?
Well, you can buy some trail mix from the store and look at the ingredient list, even if it's in a dark container.
There's no ingredient list. You bought it from the black market.
Oh.
Black market trail mix. Tyler.
Okay.
Oh, I know.
Izzy. I like Izzy.
Well, what you could do is you could take the things out and look at them. You said we could take them out.
What do you mean take the thing?
Pull
All
it
of
out
it?
of your hand.
You wanna
Just
the
dump
whole-
it out.
Oh yeah, I did.
Dump it into a
Dump it
plastic
out
bag.
and sort it out.
Annie.
To be fair, I think you need to look at all of it because if you just take a handful, you could miss like a type of nut or like an M&M or something.
Okay. What if I tell you all of it is 8,000 gallons? They measure tracks.
Black market seller really has this trail mix.
When we talk, alright, now I need your attention for some math. When we talk about a group of something, doesn't have to be people. This is where a misconception often comes in. We, when we talk about statistics, are normally discussing people and results and like information you gathered from people. But a population just references everything we are looking at. So if it was a survey, obviously surveys involve people. But if my population is like dog types or dogs, and then I'm collecting data on dog types, then it's dog, right? If I'm looking at trail mix, it's all of the trail mix. Whatever is your entire thing is your population. A sample is that handful, right? We reach in and grab a handful, but my handful is 80% M&Ms, and I don't think that's true. I reach in and grab another handful, and it's only raisins and nuts, and I'm like,
That would
wait,
be amazing.
there were M&Ms in here before. So Annie's suggestion was, well, we can't like only look at a handful because that might not be fair, right? Samples can have a bias. So a representative sample, please write this down. This is the only thing that really matters. Well, all of it matters, but I think this is one of the newer things. A representative sample, and it's going to cover all our vocabulary words, is a sample, a chunk of your population, that represents the whole population well. You didn't miss any types of nuts. You didn't miss any of the dried fruit. Your handful has every type of object represented. And hopefully, it should have the correct ratios. So if in my trail mix, I have 1/10 M&Ms, my handful should be relatively close to 1/10 M&Ms. Now we know realistically this doesn't always work out perfectly, but according to math, if we do things randomly, we should get a fairly representative sample. Now, if I only have, try and do something really small. Well, so if I only have a container of trail mix this big, is it going to be easy to collect a sample that represents everything?
No.
We never said how wide it was, so it could be like.
Well, okay, let's imagine like it's a tiny little glass. As we look at, I'll just get to what I'm trying to get. As we look at populations, the bigger your sample can be, the better. Because we assume it more correctly represents our population. Obviously, you'll get more of the population if you talk to half of the people than if you only talk to 10% of them. But we don't always have time. So as samples get larger and closer to the size of the population, they're actually better, because what if I say my sample's a handful, my population of the trail mix is only this much, and my sample's the whole thing? Well, then my sample has to represent the whole thing. Right? If your sample is the population, it's directly representative. It is exactly what it is. But when your population's humongous, 80,000 gallons or whatever we're talking about, and you look at a handful, that handful could be missing stuff. So that's when we talk about whether it's just a sample or whether it's a representative sample that correctly matches those ratios and those qualifications. That's what we're going to get into. So, any questions on that, the vocab, like what we're really talking about today? Population's everything that we're looking at. So if we're looking at skincare that 7th graders use, our population is not going to include high schoolers, right? Like that, our population is what we're looking at, what we're talking about. So as the social director of the class council, Raman would like to survey a few students about their interests. When he analyzes this survey, he wants to make claims about the interests of all students in the school. We may do this at the end of the year and present some data about Phoenix. So if you were to survey only students of the class council, for example, it might be hard to make claims on what all students think. Why? If you only, that'd be easy, right? We can talk to the people right there close to us. Cool.
Because not everyone agrees on who the class council is. That's because, they also are just different people in general.
Yeah, that class council is probably going to be like the go-getters, like people that step up to do things that other people don't necessarily want to. So students around the class council may not have the same interest, right? They may not represent. Now they hopefully, if it's a true student council where people are elected, you'd hope they represent your interests, but you can't be certain. So check this out. If Raman wanted to generalize the opinions of all students in his school, would it make sense to go to the grocery store and survey the people there? If you wanted to generalize all the opinions of students at his school, would it make sense to ask all of his friends at the school? If you wanted to generalize the opinions of all students at the school, would it make sense to ask every third person who went to the cafeteria? Take a minute, talk with your teammates. What would you choose, and what is your reason?
Don't give it back to her. Don't give it back. No.
If you ever were on task,
Okay,
I would listen to you. Would you yelling at me?
correct
That
me
was
if
such
I'm
a
wrong.
quick,
It's
dramatic.
usually your friends that think the same way. Correct?
I said I would put that.
What do we think
So,
about?
if he likes cars, most likely.
Okay, so
What the problem is,
Okay,
so if
so
he
that
wanted
sample,
to ask every person, it's
yeah, that
random.
sample.
Why would it be good?
It's not
Grocery store.
Not even
but it's random. So if you're standing in line and you said, hey, reasonable, that's random.
Exactly.
It's not random.
I like blue idea. It's still
Or maybe he's just
He
super
could be missing, and I think the best choice is to
So I think that
yeah.
Or ask every second person. I hope he doesn't have time to ask everyone. I'd be like one person, 30 or 40. But that's kind of the same thing. Yeah.
It's just a skip
I mean, it could easily be in a different order.
Well, Annie, that's like if you say it's just a school of like 1,000 like high school or something. If you if Will chooses to do every second, that kid chooses to do every second person. You said it would be that many people. Every second person would have 7 people, but if you did every third person, that would be 4.
No, I mean it's definitely different, but every other person would be more
definitely got something.
reliable. Is it a sparkle?
I hope not. Never do that and I'll quit
The data
teaching.
would be more reliable.
Somebody throws
Yeah,
glitter at me, I'm
every
done.
other person.
Dude, glitter is like a
The
disease.
person.
You can't get rid of it. It comes back 2 weeks later, and you're like, I thought I was done with this. All right, who can talk about egg? No, we don't have to. Mina or Rachel? I don't want to make that difficult.
Okay. That would not be a good sample because it's not a school, it's a grocery store. so not everybody there goes to the school.
Yeah.
Most of the people there are adults anyway.
So we could say, more specifically using our math words,
Yeah, math. That's literally what I think.
the population of the grocery store is not the population we're studying.
Oh, I understand.
The population we're studying is his student body. What about B? All right, Rachel.
That wouldn't work because most likely his friends agree with, like, they also probably gonna say the same thing because probably like in the same social group.
So if we use some math words, what would we say about that sample?
Only one, I don't know, fraction population.
Ooh, somebody said it. Biased sample. And a biased sample can be said to be not representative, right? If it's biased, it's not representative. And Naya, what about C?
C is the best option because you get everyone because and stuff, and every other is you get a better variety and represent them.
This I need you to write down, please. It has a C.
No, I know, but you didn't put a C by accident.
Systematic sampling has a rule. Sorry, buddy. Because we are following a rule, we assume that we will get a representative sample. Because as Ian posed the question, what if all of the people that we choose, even that every third, are all of his friends? Well, I really doubt that your friend group spaces them out every third person as you walk down the hallway. You normally come in as a cluster, and so you do things to avoid that, right? You don't tell people how you're going to be collecting the data. You don't divulge that information that will ruin your survey. That's like telling your student group, I'm going to decide what color people like based off cookies they take before they take their cookie.
And then they'll purposely pick the cookie they want to take.
Yeah, then they know what you're doing. Right? That's why I didn't take any cookies from Alana, because as soon as I saw what was happening, I'm like, I know this experiment. My sister did it in high school. Well, middle school. But, no, so am I right? Was that your hypothesis, what you were wondering? Will the color of food affect people taking it or not? She made cookies that were all identical, but they were different colors. They were the same food, but different colors. If broccoli was purple, do you think you'd eat, like, think about those different, like, yeah, well, why is broccoli being green not gross? Like, what, it's a color, right? What if it was orange? Or
Broccoli is so good. Would you like broccoli? Hot butter?
Cheese. Cheese.
I go with cheese on this one.
All right, we'll take a sample. Who goes cheese on broccoli? Who goes butter on broccoli?
I don't know.
You're wrong.
Cheese and butter.
Okay, so, hold up. At this point, we know what a population is, right?
Yes.
We know what a sample is, right?
Yeah.
A sample is a group from the population.
Yeah.
So, actually, if you want to make life easy,
Wait, what's the direct definition of population?
everything being studied. Like, every subject being studied. If you want a visual, this is your population, right? The entire school. Your sample comes from within that. Yeah.
So I just
Who's
remembered
there?
that we read about this in connections and neglecting probability. What you just said, planning it out and having to mirror.
Yeah.
Neglecting probability.
Yeah.
So, this does tie over to a bunch of different stuff. You guys have learned this year. Somebody already made the connection to connections class, to Earth and global cultures. So, if you want to represent all the students at your school, but you survey all the students at school 30 minutes after the last class ended, you're likely to get disproportionate disproportionate number of students who play school sports. Right? Why? You're a sports player, right?
Yeah.
All right, Kate. Why would that be disproportionate?
Let's say they have a shuttle like we do. Those people that play sports would be off to practice on the shuttle, so if you're missing a chunk of your population.
And I love how we have like skewed our perspective to Phoenix. If we were at a regular school, who's there after school ends? And the sports people, right? They stay, they practice, and drama, like people in the extracurriculars. So if we wait until after school, somewhere like here, no sports people are going to be here, right? If we consider that during like extensions, a half hour after school. But if we're at a normal school, they send everybody home and then they have practice. Only sports people are left.
Wait, but this.
Well,
But also, that would just kind of be a dumb idea. Because if you were going to do that, then, like, you should probably do it maybe near the middle of the day. Or
Yeah.
at the very beginning, because that's when most people are there. Some people might have to go to doctor's appointments, or this or that. So, probably best.
But I mean, I feel like either way, the systematic way or this, you're still gonna miss people.
so a convenience sample. I'm going to write these with you. Convenience sample. You know how to spell the word convenience? Bonus points for you.
I sure hope so.
Convenience. Convenience sample, and you don't have to keep saying sample if you like know that we're talking about sampling methods. Is selecting those around you / what's easy and fast. So if I say I want to take a sample of the mathematical abilities of students at Phoenix, and I'm going to use this class.
Well, I mean, then again, you picked the right group. Yeah.
Well, does that correctly represent?
Well, because we're in the accelerated class, and there's higher classes in the 7th grade than
Yeah.
people in 9th
There's classes above you, there's classes below you.
Even
Class.
from each class.
We are right in the middle, though.
Yeah, we're
Yeah,
right.
we're just
right.
We're the just right from the word.
Actually, doing a singular class behind us because we're second period and math 7 is English.
Do you know how many math assignments we have?
I know. Because we're second period, the only one behind us is 1.
Okay.
Yeah, but the people above us.
Do you think? So I just want to wrap this together before we move on. Do you think convenience samples tend to end up representative?
No.
No, probably. Now they could, but probably not, right? Because it's just who's around me, who's easy. Like that's going to create some kind of bias. Now, a voluntary response sample is still easy. I mean, so my wife is still learning about statistics, and she's in her master's program of college. Right? Like statistics is important. It's how we know what we know. It's how pretty much the whole world works. I mean, collecting data is how stoplights know how to last, how long they do. People stand there and they collect data and they count cars. Yeah. So, if you send out the questionnaire, say you post something on Schoology, and you're like, hey, whoever wants to, go on and take it. It's a voluntary response sample. So please write down something. That voluntary response is just like at the choice of the population. You'll get however many results people decide to give you. You'll get results from whoever decides to take the survey. It's just voluntary response. Could this come out to be biased?
Yes.
Yeah. If I make it optional, the results I'm going to get from 7th grade, no offense to those of you on the other side of this fence, but are from the people that want to go above and beyond. If it's optional, and I'm a student who does the minimum, I'm like, optional, that means no. Like, so it could be biased. However, could be representative, right? We don't know. It could, the people who respond, like maybe people encourage their friends to do it. Maybe I end up with like half the kids from the school. Maybe it comes out representative.
You could offer a cupcake.
Ooh.
They answered, and then most of them were
No, do it
I
without
would do
them
it
knowing.
multiple times.
Yeah. Do it.
Yeah, what if someone, that was what I was going to say, what if someone like just took it 1,000? Then you make it so that they can only have one.
Yeah, you set up parameters. So you do things to have safeguards against that. A lot of things like that work based off IP address. So when you are logged into a computer, you are connected to a specific IP. So to go deeper than we need to go today, the kids that have been making very poor choices around the nation and getting in big trouble for things they're posting online and whatever else, it all traces back to IP addresses. In the nation. So when you are online and you do anything, it is traceable to where you are and what computer you're using. Okay, even then, it is traceable. Everything is traceable. So you set up a survey so that it says like, oh, from this IP address they can only do one. Now you could, people really want to get around it. You can probably get around it. Now, last thing, then I'll take it in a second. Last thing we talk about is a cluster sample. Now, this is a really interesting form of sampling that we didn't used to teach you guys. And when my wife and I were talking, she was like, how do you not know about cluster sampling? So, first, you divide the students into smaller groups so that each group is representative of the population. So, like advisory groups or foundations or different ways that we break you guys up that's just kind of like random. Now, advisory grouping is like alphabetical, but we assume like a chunk of the alphabet will probably be a random group of students based off, well, in that, it is interesting to see trends, but that's based off your last name. I don't think that necessarily affects your work effort or anything like that. So, you get groups first. Then, you randomly select one group, or if one group isn't big enough, you grab multiple groups and you assume each group is going to be representative. So, if we were here at Phoenix and you had to invent a new way to do this, how might you break up clusters? That's not a cluster. Okay, male and female could be clusters. Okay, now is that going to represent? Okay. Letter group could be a cluster. Yeah, letter groups are based on class. Alright, so we're going to keep talking about these as we go. Alright, so you decide from what population, what is the group that we're talking about. So they say call every 100th name in the phone book. In the phone book tells you the population is people in the phone book. Yeah, I mean, as long as you're internalizing this information, I'm not really asking you guys to write a lot. I'm just asking you to like learn and think. Ava, if we survey people who come to the Vote Now booth at the high school football game, what is our population? So what we're really asking is we're getting a sample from what group? Like what is? Yeah, yeah, people who want to vote at the football game. Right, because where we are, the booth we're at, I mean, if you come up here, you're probably, but if we try to speak really easily, population is people at the football game, right? So we're saying at the football game. No, it's like information about voting, like maybe where you would register or something like that. So people at the football game. I was at the games and I wasn't really a fan. I was a drummer. Ask every 10th student entering a high school football game. The law.
It's the systematic, so then it would be the students in the
Ooh.
I mean, students.
Students at the football game. Now, even though it's a high school football game, are you certain every student is a high schooler? No.
We go to football games.
Exactly. But if you're only looking at students, like you're like 1, 2, you're an adult, 3, like you skip, then you're only looking at students. Doesn't matter. Well, okay, you have to say like, are you a student? Okay, all right. You have to know something, right? Haphazardly, such a great word. Haphazardly survey students during the morning break. It means like without any order or system or any like you just kind of willy nilly. If you've ever heard willy nilly, there's another good one.
I've heard it enough.
Alana, what do you think? Yeah, well, what is your population then? The big group that you're pulling from. Yeah, just students, right? Because it's at break, we're just randomly, we don't even know where we are, so just students, right? That would be our population there. Text response to an online instant poll. You're online and a thing pops up and it's like, we want your opinion. Is it? Okay, but what is your population? That's your sample is people who respond. What's your population? Even broader. This is how you respond, right? But it is so if you've ever, and hopefully you're not on like sites that pop up with this stuff a bunch, because don't click on that stuff until you get viruses. But when things pop up and it's like, hey, we want your opinion, I'm gonna close that. Right? I'm not gonna give my opinion, but some people will. So I was part of the population, right? I was asked the question. I just didn't respond. So it's voluntary response. Kind of random in a way, but it's voluntary response. Hand out surveys in the library before school. What is your population there? And if you want to tell me what it is, yeah, so people in library before school, right? We don't even necessarily know that it's students, because it could be teachers or whatever else. What kind of sampling is that? Well, maybe. Yeah, I hand out surveys. I don't know how many I get back though, right? So it's still again kind of like a voluntary response because they got to give them back to me.
Yeah.
I gotta be obedient because it's like they're all in one place.
Yeah, they're close to me.
But they also can.
Yeah.
I gotta be
So I didn't break up the group in the library though. To do cluster sampling, you as the surveyor, or so like you have to make the choice to make sure you have representative groups broken up. I don't know that the people in the library represent the population. Survey all students in period 1 English class. Annie? So what's your population though? Because that's your sample. You surveyed all of them, the whole class. So what's the population? Yeah, your students, right? Your high school, Now we could even, this wouldn't be fair. Well, let's say I go over to the academy, and I survey everybody in the academy. And then I say my population, you with me, Ava? Then I say my population is all Worthington high schoolers. Is there an issue with that?
Yeah, they are Worthington high schoolers.
Well,
They are Worthington high schoolers.
the academy is a high school program.
So they are Worthington high schoolers, but it's not all of them. It's all of them in the academy Worthington high school.
But that's a sample.
That's a sample, but it's not a whole sample. It's not the whole population.
Well, it is a whole sample. If I say it's a sample, that's a whole sample.
But, so, it's not the whole sample.
So what are you saying it isn't?
It isn't the whole population.
No, what's the math word? It isn't. We wrote it down on the last slide. Mia,
Representative.
it isn't representative. Right? Those kids decided to come here because they didn't like the traditional high school. They didn't like the people. They want to get ahead. I know people over there because they're just trying to graduate early. Like, that's a very specific sample. It's not representative of all of Worthington, most likely. Because a lot of those kids at the traditional school are just like, I'm going through my day, whatever. They're the normal, right? The variety of kids. Over there, that's special. They made that choice to go there. Like, you guys made the choice to come here. You are probably a pretty good sample because you're in middle school and some of your parents kind of swayed that choice. Yeah, you're maybe representative. It'd be kind of arguable. We're running out of time here. We've only got like a minute left, but does it make sense what we're talking about, like validly representing a population versus not?
Yeah.
That's really the gist of this, and understanding the different sampling techniques. That's really it. You break up the groups to each be representative. That's the biggest thing about when you break them up. So I couldn't break up. So imagine cluster sampling here, and I break up 7th grade into groups, and I break up 8th grade into groups, and then I want to do a survey about all middle school. That doesn't work because my groups are not representative of all middle school. So I'd have to break up my groups from the get-go with a mix of 7th and 8th graders, boys and girls. No, then you pick an entire group. So you break up the groups.
You only eat the M&Ms and don't eat the rest?
So this moved. Correct. Where am I? Sorry, this totally moved.
Right here. Sorry, I
Okay. Cluster sample. Divide the students in smaller groups so each is representative. Then randomly select a group or multiple groups if you need more people than what are in one group. So if my group's end up being 10 people and I want 30, wouldn't it be what? Not if each group was representative. Say I want to do a survey about middle school students, and I make individual groups that are each boys and girls, 7th and 8th. And I make sure there's like a good mix in there of personalities or whatever else. Crap, I have papers more than a dog. Okay. Have a good day, guys.
You too.
Thank you.